Hello, good evening, students. Welcome back. So we are discussing the topic carbon and its compounds, right? So far, what all things we have covered? So we have covered the electron dot structures. Okay, so of some of the important compounds, right? So these were the things which we have covered in our previous classes. Okay. Then we have seen what are the types of compounds. We have seen what are the types of compounds. Okay. So then we have seen what are homologous series, right? So what are the homologous series? Then we have seen the set of series of alkanes, alkenes, and alkynes, right? So alkanes are those. So these are the saturated compounds with single bond, right? Okay, so carbon, hydrogen, they have a single bond, and your alkenes, they have a double bond. Okay, that is carbon-carbon bond contains double bond. And alkynes, okay, alkenes and alkynes together, they are called as unsaturated compounds. And alkynes, they have a triple bond between the carbon atoms, right? So they are called as what? They are called as the unsaturated compounds. So these things we have covered in our previous classes. Then we have seen the type of heteroatom functional group, okay, and the formula of this functional group. So when you have a oxygen, so there are different functional groups. You can see alcohol, it results into alcohol, aldehydic group, ketonic group, carboxylic group. Okay, so now we are going to see some of the important alcohols. Okay, so we are going to see some of the important alcohols. So the first one is, so these are the, what you can see, that is depending upon the number of carbon atoms. Okay, so these are the, what you can say, names, how you give them. So when you have one carbon, it is called as meth. Okay, as we know, it is meth. And the suffix which you put is what? All. Okay, so it is methane all, OL. Okay, all is the suffix. Give me just a. Okay. So coming back, okay. So as I said, so when you have one carbon, okay, when you have a one carbon, then it is called as what? Methane. Okay. So alcohols, whenever you have alcohol series, okay, so it ends with all. What it ends with? OL. Okay. Now methane. So methane, and so because you have one carbon atom, okay, and it ends with all. So it is methanol. So the formula, molecular formula is CH3OH. What it is? CH3OH. So what is happening when you have a alkane, that is your methane. So first is your methane, right? So what is happening in alcohol? One of your hydrogen atom is replaced by OH group. Okay, so it results into a alcohol. Understood? So methane. So your alkane, it is methane. So what we are doing? We are replacing this E by OL. Okay, so this is the what you say rule. Okay, how you write it. Then when you have two carbon atoms, when you have two carbon atoms, okay, then it is called as what? Yeah, ethane. Okay, ethane. So what is happening here? You are replacing your E by OL. So the name is ethanol. Okay, so the name is ethanol. So the structure is CH3, CH2OH, right? CH3, CH2OH. Ethane is what? CH3, CH3, right? So what is happening here? One of the hydrogen atom is replaced by OH group. So it is called as ethanol. Next, third one is propanol. So when you have three carbon atoms, okay, when you have three carbon atoms, then it is named as what? Propane. It is named as propane. Okay, so what is happening here? E is replaced by OL. Okay, your E is replaced by OL. So it is propanol. Okay, so you have three carbon atoms. So CH3, CH2, CH2, OH. So this is the molecular formula. You can see the structural formula also. Okay, so structural formulas are given in the last tabular. You can see, so this is the structural formula. So methanol, this is the structural formula for methanol, ethanol. Okay, then this is propanol. So structural formula here, they have given the complete structural formula. You can see carbon hydrogen bonds are com completely elucidated, right? Okay. Now moving forward, when you have butanol, okay. What do you mean by butanol? When the number of carbon atoms are four. Okay, when the number of carbon atoms are four, then it is termed as butanol. Okay, so butane. So your E is replaced by OL. So it is butanol. Okay, so carbon atoms are CH3, CH2, 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 OH. So this is the molecular formula. Okay, so this is the molecular formula, that is butanol. So this is a structural formula. So the structural formula is given here. You can see. Okay, so it is completely elucidated. So this is the butanol. Okay, the molecular formula and the structural formula. Fine. Now next is pentanol. Pentanol means when you have number of carbon atoms is five. Okay. So the number of carbon atoms are five here. You can see, right? So what is happening here? Pentane. Okay. So pentane means five. So E is replaced by OL. So it becomes pentanol. Okay. So this is the molecular formula and the structural formula. So like this, we name the compounds. Okay. So like this. So these sets of compounds, they are following what? They are following the alcohol series. So these are homologous series of alcohols. Okay, so this is the example of homologous series. Okay, so this class of compounds, they belong to alcohols. Then the next compounds, the homologous series is the aldehydic series. Okay, next is what? Aldehydic series. So you can see what are the aldehydic series here. So it starts with again. Okay, so remember that it is same. Okay, methane. So first is your methane, one carbon, two carbons is ethanol, ethane. Okay, propane. So what? Whenever you have aldehyde, so your prefix means the word which you add before. Okay, and suffix means the word which you add later. Okay, after the word. So suffix aldehyde. So for aldehyde, we are adding al. Okay, for aldehydes, we are adding what? Al. So for suffix aldehyde, we are adding al. Okay, and for alcohol, we are adding ol. So don't get confused. So for aldehyde, we'll add al. Okay. Now here, so methane. Okay, so whenever you have methane, so E is replaced by your al. Okay, E is replaced by Al. Okay. So what is happening here? HCHO. Okay. H C double bond O H is nothing but your methanol. So this is the molecular formula. This is the structural formula. Okay. Next is ethanol. Next is what? Ethanol. That is the number of carbon atoms are 2. Okay, so here you can see the number of carbon atoms are 2. Then what it is called as? It is called as ethanol. Okay, CH3, CHO. So CH3, C double bond O. Okay, H. So this is the structure of what? Methanol. Okay, so this is the structure of ethanol. Fine. Here it is given C in the, so this is the molecular formula and this is your structural formula. So don't get confused. So this is your molecular formula, this column, and this is the structural, okay, complete structural elucidation of this particular compounds. Next is propanol. Okay, propanol, number of carbon atoms are 3. So 1, 2, and 3. Okay, so propanol, and this is the structure. So please go through the structures. Okay, I'll just go forward. Next is butanol. Okay, when is butanol? So your E is replaced by Al. Okay, so the number of carbon atoms are 4. You can see 1, 2, 3, 4, right? So the number of carbon atoms are 4. So then it is termed as what? Butanol. Okay. So here one carbon atom is extra. Fine. So this is butanol. So CH3, CH2, CH2, C. So these are the four carbon atoms. Okay, so this is the molecular formula and this is the structural formula of the compound. Then pentanol, the number of carbon atoms are 5. So 1, 2, 3, 4, and 5. Okay, so this is the pentanol. So what is happening? What we are doing? So these are the sets of compound. Okay, that is a homologous. So these compounds, they belong to homologous series. Okay, and these are the sets of compound which belongs to aldehydic group. Okay, they belong to what? They belong to aldehydic group. Fine. Next is ketones. Okay, next is what? Next is ketones. Okay. Now ketones, how do you start with ketones? Okay, so these are some of the ketones you can see. So propanol, okay, propanol means number of carbon atoms are 3. Okay, so your prefix, okay, so prefix is the same. Okay, methane, ethane, propane. Okay, so your E, that is, if I takes your prefix as methane, so your E, okay, E is replaced by ONE, okay, own, ketone, okay, ONE is the what? Your suffix, okay, ONE. I'll write it here, ONE, okay, ONE is the suffix whenever you have a ketone group, okay. So ketone is represented by C double bond O. Fine, that is R and R dash will be there. Okay, so propanol, the number of carbon atoms are 3. So this is the molecular formula of propanol and this is the structural formula of propanol. Next is butanol, that is the carbon are 4. Okay, butane, E is replaced by ONE. Okay, E is replaced by ONE. So this is molecular formula and this is the structural formula. Then pentanol. Okay, pentanone, your E is replaced by ONE. Your E is replaced by ONE, that is pentanone. Okay, so this is the molecular formula, this is the structural formula. So 1, 2, 3, 4, 5. So the number of carbon atoms are 5. Okay, so when you have the number of carbon atoms are 5, then it is pentanone. Then 6, hexanone. Okay, hexane. So what is happening here? Your E is replaced by ONE. Okay, so hexanon. So 1, 2, 3, 4, 5, 6. Hexanon. So this is the structural formula. Then going forward. Okay. Next is what? Heptanon. Okay. Heptanon means what, students? Heptanon. Heptanon means when the number of carbon atoms are 7. Okay, when the number of carbon atoms are 7, then it is termed as heptanon. Okay, non because your E is replaced by ONE. So number of carbon atoms are 1, 2, 3. Okay, 1, 2, 3. So it is CH3, CH2, 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 1, 2, 3, 4, 5. Okay, then 6 and 7. So 1, 2, 3, 4, 5, 6, 7. Okay, so this is the structure of heptanol. So this is the structure, this is the molecular formula. I hope this is clear. Okay, so these are the homologous series of ketone. Okay, so these are what? These are the homologous series of ketone. Okay, fine. Moving forward. Okay, so we have seen the different compounds and their groups. Okay, these are the series. Next set of series we are going to see of carboxylic acid. Okay, so these are also important functional group, carboxylic acid. Okay, it is given as C double bond O OH. Okay, C double bond O OH. Okay, so the prefix same, it remains the same. Okay, so methane, ethane. So what is happening? Your E will be replaced by oic acid. Oic acid. Okay, your E will be replaced by oic acid. Your E will be replaced by what? Your E will be replaced by oic acid. Your E is replaced by oic acid. Okay, so methanoic acid. So this is the structure of methanoic acid. Then ethanoic acid. Okay, CH3COOH. So this is ethanoic acid. Number of carbon atoms are 2. Next is propanoic acid. Number of carbon atoms are 3. Okay, so this is the molecular formula. This is the structural formula. Next is butanoic acid. Okay, butanoic acid, the number of carbon atoms are 4. Okay, so this is the molecular formula. This is the structural formula of butanoic acid. So remember the suffix. So suffix are different for different functional group. Okay, so for alcohols, we are taken all. Okay, for aldehydes, Al. For ketone, ONE. And for your carboxylic acid, oic acid. Oic acid. Okay, so these are the suffixes for different functional group. your prefix will remain the same. Okay. So methane, ethane, okay, propane, okay, butane, pentane, hexane, heptane, octane, nonane, decane, okay. So these are the prefixes. Only your E will be replaced by the suffixes, this particular suffix, okay. So these are the sets of your what these are the sets of compounds which are belonging to carboxylic acid. Is it clear, students? Okay, so these were the sets of compounds. Okay, these are the sets of okay compounds which are following the homologous series. Okay, so next we are going to see is the isomerism. Okay, what do you mean by isomerism? So these are some of the important concepts, okay, from this particular chapter which I am talking about. So isomerism is also important concept. So you may get some questions on that also. Okay. So isomerism. Okay. So two or more compounds which are having same molecular formula. What do you mean by isomerism? So when you have two or more compounds, okay, when you have two or more compounds and they are having same molecular formula, okay, but where they differ in the chemical and the physical properties, okay. So you can say that there are five students in the class, okay. So how they will differ? So all the five students, they are in the sixth standard, okay. So they are in one class, that is sixth standard. But how they are differ? Yes, they are differ by the ability to grab the studies, okay. So it depends on how they take it, right? So depending upon their physical and chemical property, depending upon their performance, you will decide how they are in the class, okay, they are in the group, you can say. So those two or more compounds, okay. So these all students are belonging to sixth standard, but how they are they are differing based on their performance. Same way, when you have two or more compounds, they are having same molecular formula, okay. They are going to have same molecular formula, but they are differing where they are differing in the properties, okay. They are differing where they are differing in the properties, that is their physical and chemical properties. So they are called as isomers, and this phenomena is called as isomerism. Then this phenomena is called as what? Isomerism. Okay. Suppose I take two compounds. Okay. I take one compound. Okay. That is butane. What is butane? Butane is the compound. Okay. It is a alkane. Okay. Saturated alkane with four carbon atoms. Okay. So I'm going to use this formula, that is CnH2n plus 2. So N is equals to 4H 2 into 4 plus 2. Okay, so it becomes C4H, 2 4s are 8 plus 2 is 10. Okay, so C4H10. So I can write, so butane. So butane can be written in two different forms. Okay, so it can be written in a straight chain compound. Okay, you can see the straight chain compound of butane here. Yes, students, can you see it clearly? So this is the so the molecular formula, it remains the same. Okay, the molecular formula, it remains the same. Only differing is there in their structural formula and their properties. Okay, so this is a butane. This is a straight chain compound. You can see it is called as N-butane. Okay, when you write a straight chain compound, then it is called as N-butane. Okay, and this is isobutane. Okay, isobutane. How do I write isobutane? I'll show you. There CH3, CH, CH3, CH3. Okay, so this is the okay. So this is the isobutane. So N-butane, isobutane. Okay, so these are the what you called these are the compounds. Okay. Right. So when you have isomers, so whenever you have the butane, so the butane can be two butanes. Okay, so the molecular formula, it is same. So what? It is N-butane and isobutane. Okay, N-butane means when you are writing it in a straight compound. Okay, isobutane means what? When you are writing like this branched form. Okay, branched form, it is called as isobutane. So you can check in both the forms. The molecular formula is same. The molecular formula is same, but what is happening here? They are differing in their properties. Okay, they differ in the properties. Okay. So these are the examples. Isomerism means what? When two or more compounds, when they are having same molecular formula, but when they differ in the chemical and the physical properties, okay, then they are called as isomers. Fine. So these are the just students, 2 minutes. Huh? Okay, so we were discussing about isomerism, right? So when you have two or more compounds, you can see in this example that the molecular formula is same. Okay, in both the cases, the molecular formula is C4H10 only. Okay, but how they are differing? They are differing in the structural formula as well as the properties, right? So this is a straight chain compound. This is a branch chain compound, right? And their properties also differ. Fine. So this is the isomerism. So please remember the definition as well as the example. So you can remember the best example, that is isomers of butane. So you can write this. So this is a straight chain compound and this is a branch chain compound like this. Okay. So this is your isobutane. Fine. Okay. So this is also an important question. What is isomerism? And give an example. So it can be asked for 2 marks. So please study this. Okay, moving forward, next we are going to study the chemical properties of carbon compounds. Okay, so these are some of the reactions. Okay, so how carbon compounds they undergo different reaction. So first, carbon compound can undergo a combustion reaction. Now, what do you mean by combustion reaction, students? Yes. So this reaction where your hydrocarbons. Now, hydrocarbon means your methane. Okay, methane. Okay, your fossil fuels. What is fossil fuels? Petrol, diesel. So these are all what? These are all hydrocarbons. Okay. So hydrocarbons, when this methane, okay, when it methane, it burns. How does the your vehicle works, right? Your vehicle works with on the basis of combustion, right? So fuel is nothing but hydrocarbons. So hydrocarbons and your air, okay, that is in the presence of air, what will happen? The vehicle, okay, it produces combustion reaction. Okay, it produces combustion. So like that. So combustion is what? The reaction in which the methane burns into the air. Okay, the methane, what happens to methane? It burns into the air to give you carbon dioxide, water, heat, and light. Okay, so this is the combustion reaction. So methane, when it reacts with air, what does air consist of? Air consists of oxygen. Okay, so it forms what? It forms carbon dioxide gas, water. Okay, heat is produced. Okay, heat is given out. Okay, excess of heat is given out, right? So heat is given out, that is it undergoes the exothermic reaction, heat is given out and light is given out. Okay, so these are the This is combustion reaction. So whenever the methane, okay, how does methane burns? Combustion reaction means it should follow or it should go in the presence of air only. Okay, it should go in the presence of what? It should go in the presence of air itself. Fine. So then it is called as what? It is called as combustion. So whenever combustion occurs, this combustion always occurs in the presence of air. Okay, and it releases more of carbon dioxide gas. Fine. Next, so you can see example here. So I had written the example, that is when methane is your CH4, it reacts with oxygen. So in the air, what is present? Oxygen. So it gives you carbon dioxide plus water, okay, and heat is produced. So heat is nothing but exothermic reaction. So whenever the heat is given out, okay, it is a exothermic reaction. Fine. Next is oxidation reaction. So we have studied about oxidation reaction. Oxidation reaction means what? Addition of oxygen. Okay, addition of oxygen is your oxidation reaction. So whenever alcohols are there, okay, alcohol is what? ROH. Alcohols are ROH. Okay, so whenever alcohols are to be converted, okay, whenever alcohols are converted to carboxylic acid. So what is the formula of carboxylic acid now, students? It is RCOOH. So what is, you can see here, there is one OH, here there are two OH. So there is what? There is a addition of oxygen. Okay, so this is what? This is your what you call oxidation reaction. So alcohols, when they are converted to carboxylic acid, so alcohols, they are converted to carboxylic acid. Okay, and you get what? You get, okay. So alcohol. So whenever you are adding oxygen, so whenever you are adding oxygen here, so alcohol, when you are adding oxygen, fine. So what is happening? It is converted to carboxylic acid. So you can see that in the reactant, there is only one O, okay, that is, and in the carboxylic acid, you can see two O. So there is addition of oxygen. So reactions in which oxygens are converted. So which oxygen, so how we can add this oxygen? So we can use your different oxidizing agents. Okay, we can use different oxidizing agents. So which are the different oxidizing agents? Like KMnO4. Okay, KMnO4 is potassium permanganate, or you can use potassium, that is what is that? Chloride. Okay. Potassium chromate. Okay, potassium chromate, potassium permanganate. Okay, so these particular reagents can be used. So what you are doing here, you can see example is given. So ethanol is taken. So ethanol is converted into ethanoic acid. Okay, ethanol is converted into what? Ethanol is converted into ethanoic acid. Okay. So this is the oxidation reaction. This is what? This is the oxidation reaction. So what we are doing here, we are converting our alcohols to carboxylic acid. So we are making use of what? We are making use of our oxidizing agent. So please remember this oxidizing agent. Huh? KMnO4 is potassium permanganate and K2Cr2O7 is potassium dichromate. Okay. Next is addition reaction. Okay. Next, chemical properties of carbon compounds. So chemical properties means what? How carbon reacts with different or how carbon will undergo different reactions. Okay, now here ethanol. Ethanol is what? Ethanol is a carbon compound, right? Now, so, and in the first, methane. Methane is what? Methane is also a carbon compound. So next we are seeing is addition reaction. So addition reaction is always we can do the addition reaction on a alkene. Okay, whenever you have a alkene, alkenes are what? Alkenes means the carbon compounds, okay, which has double bond. Okay, so they are called as what? Unsaturated compounds. What they are called as? Unsaturated compounds. Okay, with a carbon-carbon double bond. What? Unsaturated compounds which are having carbon-carbon double bond, which is called as alkenes. Okay, so what we are doing here, we are taking a alkene. Okay, we are going to do what? Alkene, we have taken double. Okay, we have taken a alkene. Now to this alkene, we are adding what? We are adding hydrogen. Okay, hydrogen in the presence of palladium or nickel as a catalyst. So palladium is an element and nickel is also element or a metal, you can say, and this acts as a catalyst. Now, what is the role of catalyst, students? Yes, what is the role of catalyst? What is the role of catalyst? So catalyst, what they do, they will activate the rate of energy. Okay, they will activate the rate of reaction. They will fasten the reaction. Suppose this reaction is taking place for 5 hours. Okay, this reaction to convert from ethene to ethane. Okay, from a unsaturated compound to saturated compound. When you are converting, if it is taking 5 hours, then in the presence of nickel catalyst, the time can be reduced for 2 hours. Okay, so what does the catalyst do? Catalyst will it will increase the rate of reaction. Okay, it will the time, okay, the time will be slower down. Okay, the time will be fasten up. Sorry, fine. So this is the addition reaction. So what is we are doing? We are adding the so here I'll demonstrate your the reaction. So here you can see. Okay, so here I'll write the reaction. So suppose this is a alkene. Okay, now alkene. So addition. Addition means what now? What do you mean by addition reaction? Addition reaction is addition reaction, or it is called as addition reaction, or it is called as addition of hydrogen. Okay, so here we are adding a hydrogen molecule. So how we are adding hydrogen molecule? So hydrogen molecule in the presence of palladium or nickel as a catalyst. Okay, palladium or nickel as a catalyst. Then we are taking the temperature at 150 degrees Celsius. Okay. So what is happening here? Your saturated unsaturated compound is so what is happening here? If you break this double bond, okay, then here one addition of hydrogen at one bond and one addition of hydrogen at other carbon. Okay, so this results into ethane. This results into what? This results into ethane. Fine. So this is okay. Next is substitution reaction. Next is what? Substitution reaction. So what do you mean by substitution reaction? So substitution. Now, suppose I have suppose x. Okay, x plus y. Fine. X plus y is there. So or I'll take it as Rx plus Y. Okay. So what is happening? What do you mean by substitution? It will become Ry plus X. So what is getting substituted? Your X will be substituted by Y. So this is substitution reaction. Okay. It is replaced by another atom. So what is happening in substitution reaction? One of the atom or the group is being replaced by another atom or a group. Okay. So this is called as substitution reaction. Now, again, substitution reaction is also the best chemical reaction which is shown by the carbon compound. So methane, if I take a methane, so methane when you react it with chlorine, okay, with the chlorine, what you get, you one of the carbon atom, okay, one of the hydrogen atom, so it will be replaced by your chlorine atom, okay. So thus you get what? This is a substitution reaction. So what is happening in this reaction here, students? So here there are four hydrogens, right? So in the four hydrogens, one of the hydrogens is replaced by your Cl and other H. Okay, this hydrogen will get replaced with your Cl. So like this. Okay, so this is a substitution reaction. What is happening in substitution reaction? One of the atom or a group or a atom is replaced by another atom or a group. Okay, so this is called as what? This is called as substitution reaction. Got it? Okay. Is it clear? Is the things clear? Yes. So the next last part of this particular, okay, the concept, that is the last concept of this particular chapter, is cleansing action of soap. Okay. Now, what do you mean by cleansing action of soap? Okay. So, whenever you have a dirty cloth, okay, whenever you have a dirty cloth, what you do to that? Yes, you will wash it or you will wear the same shirt next day. Yes, if you have a, if there is some stain, okay, if there is some stain on a shirt, okay. and okay, or some dirt. Okay, suppose tomato ketchup or something has fell down on your shirt. Okay, now the same shirt will you put? No, right? You will clean it, right? So what you will do, you will immerse it in a bucket. Okay, you will immerse it in a bucket which has water. Okay, and you are going to add some detergent. Okay, you are going to add some detergent into that, and you're going to what, you're going to rub that stain, and you have to you will add it in the bucket which contains the soap. Now what will happen in the detergent? Okay, in the detergent, what consists of it? In the detergent, it consists of your hydrocarbons. Okay, it is made up of a hydrocarbon chain. Okay, so the soap, it consists of a hydrocarbon chain, that is, it is consists of hydrophobic end. It consists of hydrophobic end, okay, and it consists of hydrophilic end. Now, what do you mean by hydrophobic end and what do you mean by hydrophilic? Hydrophobic means water hating, okay, water hating part, and hydrophilic means water loving part. Okay, so what will happen to the soap? Okay, so the soap or the detergent, it is made up of what? It is made up of hydrocarbon chain. Now this hydrocarbon chain, it is made up of, at one end you have a hydrophobic end, at one end you have a hydrophilic end. Now this hydrophobic end, okay, this will get attached to the dirt part. It will get attached to the dirt part. Okay, whereas the ionic end, okay, ionic end will points outwards, that is, it will move towards the water. So whatever the hydrophobic this is there, okay, and it will get attached to the dirt, and whatever the water part is there, that is the hydrophilic end is there, that will get attached to the water. So this is a cleansing action. So what will happen? Whatever the dirt particle is there, okay, dirt particles, it will be surrounded by the soap molecule. Okay, dirt particles will be surrounded by the soap molecules with the hydrophobic end, and it forms something which is called as a micelle. Okay, micelle means what? Micelle means it is surrounded by water molecules. Okay, that is, the dirt is surrounded by the hydrophobic end. Okay, then it is called as what? It is called as micelles. Fine. This so this micelle, it gets attached with the water molecules. Okay, through the ionic end, and is washed away along with the dirt particles. So whatever the hydrophobic end which is getting attached, okay, and it forms what? It forms a micelle. Now this micelles, okay, it gets attached to the water molecules. Okay, which is through a ionic bond, and it is washed away. Whatever the dirt is there, it will get washed away. Got it? So this is the cleansing action of soap. So these all things are very important. So this is the what you can say, it is a application part. Okay, so this is the application part of the carbon compounds. Okay, wherein you can see that how in day-to-day life we are using, yeah, so are we using this particular action in our day-to-day life, right? So we are using detergents, we are using soap. So how these are playing important roles in our day-to-day life is shown by this particular cleansing action. Okay. So now you might be knowing how our detergents are working on the dirt clothes, right? How the detergents are working on the dirty clothes. Now you got to know, right? So this is due to the cleansing action. So remember that in the soap, it consists of a hydrocarbon chain. In hydrocarbon chain, there are two ends. One is a hydrophobic end, another is a hydrophilic end. So hydrophobic end, it will get attached to the dirt particles, and it will form what? It will form a Michel molecule. Okay, it forms a Michel molecule. And ionic end, it will move towards the water. Okay, ionic end will move towards the water. Now, whatever the dirt particles are there, it will be surrounded by the soap particles and it forms a micelle. Okay. Now, this micelle, it will get attached with the water molecules. Okay, this micelle, it gets attached with the water molecules through the ionic end, and it will get washed away with the dirt particles. And along with that, what it will do, it will get washed away with the, it gets washed away with the dirt particles. So whatever the water will there, okay, due to this cleansing action, it will take away the dirt particles along with it. I hope this is clear. Okay, so this is the cleansing action of soap. Okay, so these were some of the important concepts which we have studied in this particular chapter, that is carbon and its compound. Okay, so what all things we have seen? So these are the things which we have seen in our class, right? So that is cleansing action of soap is very important. Then this particular chemical reactions, that is what is substitution reaction. You need to remember the what examples also. Okay, substitution reaction, addition reaction, oxidation reaction. What is combustion reaction? How, what is the definition and example? Then what is isomerism? Okay. Then what are the homologous series of carboxylic acid, aldehydes, ketones? Okay, alcohols, alkanes, alkenes, right? So these all things are very important. You need to remember what are the type of compounds, carbon compounds. Okay, so these are things are very important. I hope the things are clear. Yes, any doubts? So in the next class, we are going to see some of the important questions from this particular chapter. Okay. So till now, we have completed two chapters. That is, first is chemical equations and chemical reactions and equation. Okay, and second chapter, acids, bases, and salts. And this is the third chapter. So in the next class, we are going to see the questions also. Okay, then we have left with two more chapters. That is metals and non-metals, and one more is classification of elements and periodicity. Right. So this chapters, do you have this particular chapter for your exam? The last one, classification of elements and periodic properties. Okay, fine. So we are going to go through that also. Okay. So I hope any doubts? Is the things clear? So in the next class, we are going to see the important questions. Okay. Okay. So we'll end the session here. So we'll meet in the next class. Okay. In the next class, we are going to see the important questions on this particular chapter. Okay. So please study, go to the important things which have been covered. Okay. So this is a very important year for you all. Okay. So you have to study hard. Okay. And get good marks. Okay. Fine. So, yes. Okay then. So we'll end the session here. So we'll meet in the next class. Thank you.